Today we're looking at the intermediate value theorem. Before we actually state it, let's look at the graph here and play with it a minute. If I have a point right up here and a point right down here, I cannot possibly go between those points if I keep my pen connected to the graph, smooth like this, without crossing the x-axis, can I? There's no way to get from here to here or from here to here without crossing the axis unless I just lift my pen. And if I have a polynomial function, I won't be lifting my pen because they're smooth and connected. That's basically what our intermediate value theorem says for polynomial functions. If f is a polynomial function with a less than b, those are our two x's, then the y that goes with a and the y that goes with b are of opposite signs, then we know there's at least one zero between a and b. And that's what we were looking at a few minutes ago. It's not possible to get from a positive y to a negative y without crossing the x-axis unless we lift our pen, which is not allowed with polynomial functions. Okay, can we use this intermediate value theorem then to show that there is definitely a crossing of the x-axis, or a zero, between 0 and 1 for the function f of x equals x cubed minus 8x squared plus 5. And then we're going to find the zero. What does it take according to the intermediate value theorem? Well, one y has to be positive and one y has to be negative. Now notice the way they talked here. A zero between 0 and 1. They're talking about x's because remember when we find a zero, we find the x where y is 0. We plug in 0 for y, but we find the x. So 0 and 1 are our first and second x. What we want to find out if the f of 0 is one sign and the f of 1 is the opposite sign. If that happens, we're guaranteed a 0 between 0 and 1 for x. So f of 0 is going to be 0 cubed minus 8 times 0 squared plus 5, which is 5. So this is positive. If I plug in 1, I get 1 cubed minus 8 times 1 squared plus 5, which is going to be 1 minus 8 plus 5, which is negative 8 plus 6, negative 2. So we did change signs, didn't we, for our y? Well, if we have a positive y and a negative y, we necessarily have to cross the axis getting from one to the other. So the question is, where is that occurring? Well, we'll plug in 0 for y because that's what it means to hunt a 0, and we'll find the x that goes with it. Well, let's see. I'd like to factor it. I don't see a common factor other than 1. Do you? No. It's a trinomial, but the problem is this is not an even degree, so I'm not going to be able to come up with an x squared middle term. You know what? I don't think I can factor it. Well, now a lot of times when I can't factor something, I turn to the quadratic formula. The problem is we have to have a quadratic equation. And if we look down at this equation again, we notice with a 3 here, it's not quadratic because remember quadratic had to have a 2 for its highest exponent. This is actually a cubic equation. You know what? I think we're kind of stuck with what we've got unless we think about going to the calculator and let the calculator help us out. I think that's what we'll do. So moving over to our calculator, we're going to put in our equation on the y equals screen. And we're going to put in x to the third minus 8x squared, x to the second, plus 5. And we're going to graph it and see where it crosses the x-axis. It may cross 3 times. In fact, it does, doesn't it? There it is, 1, 2, 3, because we have an x cubed. It could be that we have 3 zeros that are real, and we do. Now, we're only interested, remember, in the one between 0 and 1. That's the only one we want to find, because we're doing the intermediate value theorem for that interval only. So let's bring our calculator back up. This is the one we want to find right here. So I'm going to second calculate, which is above the trace, go down to selection 2, which is a 0, and the calculator knows that a 0 means we're on the x-axis. So I'm going to travel downward a little bit. I'm still to the left. Notice it says left bound. I'm still to the left of that 0 right here, and I click enter. Then it says right bound. I'm going to go to the right of that 0 and click enter. And then I'll click enter again, and my 0 is 0.835388888 when y is 0. So let's write that down. X is about, and let's round it to say 3 decimal places. All right, we're going to end it at the 3rd decimal place, so I'll look at the next digit, and it's less than 5, so I'll keep this 5 right here a 5. So 0.835. Maybe put in a lead 0 so that we notice that decimal better. And x is about 835 thousandths. So it was important to have a calculator this time. We could have never factored that and gotten the answer. And that concludes this section of intermediate value theorem.